Now we will see some applications of trigonometry. But before we do that, we will just try to know some basics. So, as we have already read about trigonometrical ratios, and we have also studied some identities, etc., we will try to do some practical applications of trigonometry. Very, very usual application of trigonometry is finding heights and distances. But first of all, let us do some basics. For example, if we are suppose we are standing at some point, let us say it's A, and then there is a tower, a kind of tower on the same level, starting on the same level, and that tower is around 2 kilometers. The base of the tower, this is base of the tower, and this is where you are standing, and then obviously you will have some height also. Say you have 1.5 meter height, and you are standing around 2 kilometer, which will be 2000 meters from the base of the tower. And at the top of the tower you make some angle, that is called line of sight. So this is called line of sight, and basically what you are doing, you are making some elevation with respect to the horizontal surface on which tower as well as you are standing up. So this is called angle of elevation. And this is called a line of sight. Another thing, if someone is standing here at this point and then they are looking at you, then with respect to the horizontal, this person will also make some angle, which is called angle of depression. But you know that this line as well as this line and this line, they all are parallel to each other because they all are horizontal. So angle of depression will be equal to angle of elevation, isn't it? So I think these are some basic definitions which we should know, and then we will now try to delve into some problems. So basically here I will just take up a few problems which are from a NCERT book class 10th, which is the usual book in India. And then I would just mention it because it's free to download this book from their website. You can always do that. And then there are some exercises. The name of the exercise is exercise 9.1, which we will just try to do. So okay, the question 1. Question 1 is, a circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. So here we need to make some diagram. So let us do that. This is a vertical pole, and this is our ground. And the circus artist is climbing 20-meter long rope. And maybe he's just starting from horizontal and going all the way through. He is starting from horizontal and going all the way to the ground. So let us just try to name the points or the vertices. So what we can see here, that the length of rope is 20-meter and AC. The rope is AC here, and the angle made by the rope with the ground level is 30 degree. So there are two things. This is rope, and to the ground level, the angle made is 30 degree. So we need to find the height of the pole. So we are just trying to write down it in a kind of mathematical form, what is given and what we want to find out. So top of the tower height will be AB, isn't it? So we need to find AB, and the AC, which happen to be the length of the rope, is given as 20-meter. Okay, so this is 20-meter, and this we need to find out. Let us assume it's H. So only two things are given, this 20 and then H. This is given, this is given. What we will do, we will just try to think, is there any trigonometrical ratio which involves perpendicular, because this is perpendicular, isn't it? And this is hypotenuse. So sine 30 degree will be equal to perpendicular divided by hypotenuse, isn't it? And that is P is H, tower of height of the tower, and then hypotenuse, we can write it hypotenuse here. Hypotenuse is equal to 20 meter, isn't it? So in that way we have established the equation, and we know that sine 30 is equal to 1 by 2 or 0.5. So 1 by 2 will equal h by 20 meter, and then we will just solve that equation. We can multiply both of the sides by 20 actually, so that we get h here, and we get 10 here. So height of the tower will be 10 meter. Let us move to question number 2. First of all, I will explain the question, make the diagram, and then I will just stop, and you can try further if you want to solve the problem, and later I will also give you the solution. And remember that this is not just the solution, it is a kind of developing a thinking process on how to approach such kind of problems. Okay, so the second question is, a tree breaks due to storm. We have seen many trees breaking due to storms, and the broken part bends so that the top of the tree touches the ground, making an angle 30 degree with it. Okay, so let us make a diagram. Here is the horizontal ground, and the tree breaks from this point and in a way touches the ground. And when it touches the ground, it makes 30 degree angle with the ground. This is the ground, isn't it? The distance between the foot of the tree, this is foot of the tree, to the point where the top touches the ground is 8 meter. So after breaking down, the top of the tree is here, isn't it? And because it has broken down from here, so it's 8 meter away. Then find the height of the tree. Okay, so we have to find height of the tree now. So let us again name the vertices. Let it called A, B, C. So before we go forward, have you understood the problem? I will repeat once more. There was a tree. It was standing right here, and this is the horizontal ground. Due to storm, it broke down from here. Maybe it was standing tall before the storm, but after the storm broke out, it just broke from this point, and the top of the tree, this is top of the tree, which is now on the horizontal ground, is 8 meter away from its base. Then find the height of the tree. So what will be height of the tree? height of the tree will be in this diagram AB plus AC, isn't it? And why AB plus AC? Because AB is still standing tall, but AC is the part of the tree which has actually um, broken down, and now it is tilting and making the angle of 30°. So we need to find AB plus AC. This is what we need to find. Again, it's given that BC is 8 meter. So now again, this part AC will be hypotenuse, that we will denote by H, and as this is the 30° angle, so in this right angle triangle, this will be the base and this will be the perpendicular. So let us apply the rule for sine. Sine 30° will be P by H, or 1 by 2 is equal to P by H. But we don't know either P or H. But this will be a useful relation because we need to find H in order to find the whole height of the tree, isn't it? Okay, let us apply one more thing. Cos 30° is B by H, and the value of cos 30 is root 3 by 2, which is equal to B, which is 8 meter, divided by H. So just by rearranging, we will get the value of 8 H as 8 into 2 divided by 3. So that is 16 divided by square root of 3 meter. That is H. And that is one of the sections of tree. So that is good that we have found it. But we also need to find P, isn't it? But we can take help of this formula because we already know the value of H. So I think it's always good to write fraction divided by fraction like this, so that we don't do any mistake. And then just leave the P here and shift this, or maybe we can say that multiply both sides by 16 divided by 3. So in that way, here only P will remain, but here so this way we got the value of P. Now what is the height of the tree? It is AB plus AC. AB plus AC. But AB is P, and we have already found out what is P. 8 divided by root 3 plus what is AC? AC is H. That also we have already found. 16 divided by root 3. So we can just simplify a little bit here. 16 plus 8 is 24. So this will be the answer. And then later we can also simplify it a little bit more. So height of the tree will be 8 multiplied by square root of 3 meter. You can also convert that into decimal. It's upon you. So this will be the answer. Let us take the next question. The next question is, a contractor plans to install 2 slides for the children to play in a park. For the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meter and is inclined at an angle of 30 degrees to the ground. Okay, so this is for the smaller children. It tries to make a slide. Again, we will just give the vertices some name. So AC is the slide where children will slide, and he intends to make the overall height is 1.5 meter, and inclination 30 degree. So that is one thing. Whereas for elder children, she wants to have a steep slide at a height of 3 meter. Okay, so for the elder children, height of the slide is 3 meter, and the incline is 60 degree. This is 90, this is also 90. Let us call it DEF. What should be the length of the slide in each case? Okay, so what we are required in this smaller slides, length of the slide will be AC. So AC is what is required to be found out, and here the length of the slide will be DF. DF is to be found out. Okay, and so here we can see that we can apply this P by H, perpendicular by hypotenuse, which is equal to sine 30 degree. Sine 30 degree is equal to perpendicular divided by hypotenuse. Hypotenuse will be the length of the slide, or 1 by 2 is equal to 1.5 divided by H, or H will be 2 times 1.5 meter, that will be 3 meter. So for the smaller children, the length of the slide will be 3 meter. Okay, let us find it for elder children. Here, sine 60 will be equal to perpendicular divided by H. We can call it H1 here. And sine 60 is equal to root 3 divided by 2. So solving these equations, we get the height of the length of slide for elder children as 2 times root 3 meter. So these are the two things which were required to be found. So we have solved this